All right, so we're still in section 7.2. We spent some time doing sines, integrals of sines and cosines to various powers. Now, here's the deal with sine and cosine. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Sine squared plus cosine squared equals 1. Those three ideas together allow you to do a lot of integrals that are powers of sines and powers of cosines. That's what we did yesterday. Today, we noticed that tangent squared x plus 1 equals secant squared x. The derivative of tangent is secant squared. The derivative of secant is secant x tangent x. That means we can do integrals that have secants and tangents together. We can do integrals that have tangents to various powers, secants to various powers, because we have substitutions to get us to various chain rule situations. And the same thing happens with this crew when you have the cotangents and the cosecants. So what's really interesting is you're going to have integrals of powers of tangents and tangents and secants, powers of cosecants and cotangents. All of these use the same kind of ideas we did for yesterday's examples of sines and cosines. You have substitution rules available, and you have chain rule available. You just cobble together something so that you get a doable integral. Like this one here, since the derivative of tangent is secant squared, you really think of this as tangent x inside. Here's the derivative of the inside. All I have to do is the derivative or the antiderivative of the outside. And I'm done. So that one is a shorthand example of what we try and get. Any of these integrals in terms of these guys, you try and get it into a form that you recognize. And then the other thing to notice is you might be saying, hey, what about a tangent with a cosine? Excuse me. But nobody would give you this because tangent is sine over cosine. These cosines cancel. It's just the integral of sine x. So it's another thing to take heart from. We're going to have integrals with trig words in them, and the ones that we're watching are the ones that are going to be the most common because they have derivative formulas and trig formulas related to each other, and other combinations don't even happen because they simplify out. So you focus on these and be able to work on these. 7.2, keep working on 7.2.